Now we're gonna look at the one of the method of preparation of alkane. It is from alkene, and this particular reaction is known as catalytic hydrogenation. Catalytic hydrogenation of alkene. So we have a alkene, we H2Ni platinum palladium, we use the catalyst, and it forms CH alkene. It forms alkene. So what happens? We nickel catalyst. Let's say we use the granules of nickel, very fine powder of nickel. So it increases the surface area of the nickel, and electrons are on the surface of nickel, like hydrogen. Hydrogen is on the surface of the nickel. The electrons are flowing, and hydrogen adsorbs on the surface of the nickel. Now this hydrogen attacks. This hydrogen adsorbs on the surface of the nickel. Now it attacks on C double bond C, and it attached over here. So it forms C H and CH. So that's how it absorbs from the same side, and this same side is known as syn addition. This same side addition is known as syn addition. Now this syn addition is what? Let's say if we talk about the rate of the reaction. So rate is inversely proportional to the surface area of alkene. Let's say we have this two type of alkene. So where is the more rate? More rate is on the second because it has less surface area. Now let's take some more example regarding the rate. We have this compound and we have this compound. So rate is actually greater in case of second because it has less surface area. Again, the surface area is the reason. One we have this. So first is the more prior. We have CH3, C triple bond C, CH3, and this compound. So first we'll have more because the triple bond has more rate as compared to double bond. One we have a trans alkene and one we have a cis alkene. So cis alkene has more rate because here rate is also inversely proportional to the stability of alkene. Inversely proportional to the stability of alkene because surface area is same. When the surface area is same, then we decide according to the stability of alkene. Where alkene is less stable, rate will be more. Because when alkene is less stable, it will be more reactive. If we solve some problems, we have to compare the rate. Compare rate of hydrogenation. Obviously, the question is regarding hydrogenation. So first has more rate because it is less stable. Second, fifth, Now if we compare the rate of alkene, first we have in second we have the less stable alkene will have more rate. Third we have less stable. Fourth also it has 1 2 3 4 5 6 7 8. It has 8 alpha hydrogen. It has 1 2 3 4 5 6 7 7 alpha hydrogen. So rate will be more in case of 7 1. Again we will be counting the alpha hydrogen. So second will have more rate. In sixth question, what we have first compound is anti-aromatic. This is anti-aromatic ring, and this is non-aromatic. So anti-aromatic is less stable because we have seen in aromaticity. Let's look at some more problems. Seventh, we have a benzene, and we have this compound. Eighth, so just try to write with me and solve by your own. 9. H2 and nickel reaction 10th. H2 and I. Here we have one equivalent, here we have one equivalent. 11th. H2 and I, one equivalent we have. So here first seventh question, the rate is more in case of second because it is anti-aromatic, less stable, and in case of 8 it is first one. Now this question we have H2 and I one equivalent. So which is less stable alkene, which is not stabilized by resonance or not part of aromatic system, is less stable, so it will react first. Which is less stable will react first. It is also less stable, it will react first. So which is less stable? First ring one is less stable because it has less number of alpha hydrogen, so it will react first. Let's solve our 12. H2 and I, we have one equivalent. 13. H2 and I, one equivalent. So now it will gonna react like this, and it also gonna react like this, which is less stable, will have to react first. Now let's say we have question CH2 double bond CH, CH2, C triple bond CH. It will react with H2 and I, one equivalent. So the reactivity of the alkane and alkene, the alkyne react fast because of it has more number of electron density is more, so hydrogen will absorb more here. First hydrogen will absorb here, and let's say we have CH2C. Here also we have H2 and I nickel in one equivalent. So again alkyne will react first. 16th. H2 one equivalent nickel. So it's gonna react like this. (17) We have this type of compound, quite popular question. It react with hydrogen, 3 moles of hydrogen. So which will go? So actually this ring, if we react all the double bond on the central ring, then what will happen? This anti-aromatic, this 3 anti-aromatic ring will become non-aromatic. Repeat to me. When we remove these 3 double bond, so this 3 anti-aromatic become non-aromatic. So we have to remove this first. So reactivity of central benzene will be more. Eighteenth, we have CH3, C double bond C, CH3, hydrogen, hydrogen. When we will react deuterium with nickel, so what will happen? It will form erythio. And when we react 19th, the trans, it will form 3O. It will form erythio and it will form 3O. This is known as, what is erythio and 3O? So when we have a trans-like situation, like hydrogen are different, deuterium are there. Hydrogen, wait, its mirror image will have here it has deuterium and hydrogen. So what will happen when it has trans-like situation? This is trans, D and D are opposite, H and H are opposite. Then it is known as T4 trans, T4 3O. And we have when on the same side, this is called the erythio. Actually, this is a meso. It is a meso because it has mirror image. But when this CH3 and CH3, these two groups are different, then it won't be meso, but it will similar to the meso. Repeat me. When we have CH3 and CH3 group and the mirror image over here, then it is meso. But when there is no mirror image due to this CH3, and if it was there C2H5, let's say here it was C2H5, then what will it won't be meso, it will be erythio. Similar to this is 3O. If it was CH3 and it was C2H5, it was 3O. So right now we can say it is meso or erythio. Okay. So we have to remember one CSE and TST. So when cis has syn addition, it will form erythio. When trans has syn addition, it will form 3O. So this mnemonics we have to remember. CSE, TST. Let's solve some more problem. 20th problem. Hydrogen we have. When it react with deuterium with nickel, one equivalent. Obviously one equivalent will react with. So it will form D, D, H and H. 21st. Let's say we have CH3. D2 Ni. Here it is D, D, H, CH3, CH3. And again, one thing could also be possible. D, D, CH3 and H. 22. We have this compound. Again now, this will give D2Ni. It is C, cis Se. It will form erythio. This is trans, not cis. It is trans. TST. It will form 3O. Now this is the perfect condition for 3O. This is pH HD 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 DH and pH. Now it is not it is similar to the when it was same. It is not same. The terminal group on the vertical line are not same. Then that's why we got it 3O. We have 23rd question. So when will react D2Ni? It will be when both the deuterium are on the same side of the methyl group and both the deuterium are on different side of the methyl group. So these two are diastereomers. Both these two are diastereomers. 24th. We have this compound CH3. This is optically active now. When it reacts with hydrogen and nickel, it will become optically inactive. Optically inactive. Now let's see a type of question. We have one more type of question. Let's see. We have hydrogenation of benzene. What happens? Let's say we have a triple bond. When we with hydrogen nickel, it will form alkene, cis alkene. Hydrogen and hydrogen. When further hydrogenation, it will form alkane. Now, when benzene react with, similarly, when benzene react with hydrogen in presence of nickel, it will be a slow reaction. Initially, the reaction will be slow because aromatic has to be converted into non-aromatic. Hydrogen when nickel it react faster, and again hydrogen with nickel react fastest among this. So this will form. So on the basis to this, let's solve some problem. So it will continue till product is formed. So what happened here? We have benzene 1 mole. We have 3 moles of hydrogen, nickel. It will form cyclohexane. So it was, let's say, 1 minus x moles. It was 1 moles initially. So 1 minus 3x and it will be x. So this hydrogen is limiting reagent. So 1 minus 3x equals to 0. X equals to 1 by 3. So it is 2 by 3 form. It was 0 and it is 1 by 3. So in final solution, we have benzene 2 by 3 mole and cyclohexane 1 by 3 moles. So what will happen? What in final solution? What we have in final solution? We have both. Benzene also has, and we also have cyclohexane. Now, similar to that hydrogenation, there is one more compound which hydrogenate, that is NH2 in presence of H2O2. So how does NH2 this NH2 is known as hydrazine. So when H2O2 HOOH this breaks from 2OH free radical. Second, NH2 it will react with OH2, OH free radical will come here and it will form 2H2O plus N double bond N, H and H. So this final compound will form, it is actually cis because both are removing from the same side. So it is will be a cis type compound hydrogen, hydrogen. One lone pair will be this side, one lone pair will be this side, because both of the OH minus have attacked from the same side, right? So it will act similar to the, if we react with CH3, CH double bond, CH and CH3, it will form NH2, NH2, then H2O2. So it will react to form CH3, CH2, CH2 and CH3. It will be a syn addition to the hydrogen. How syn addition? Let's look at the mechanism. In mechanism, let's look what does it follows. Let's say we have CH3, CH, double bond CH and CH3. So when that N2H2 forms, this N2H2 attacks from the same side. So NH3, what it will form? It will form CH3, CH, CH, CH3, and this double bond will try to come here, N double bond N, H. Now this hydrogen will go here and this nitrogen will come out. So it will be CH3, CH2, CH2 and CH3, and nitrogen gas will come up. So it is also CSE, TST, cis syn rethio trans syn addition 3O. So let's say we have CH3, C double bond C, CH3. We have 2 deuterium. It will react with NH2, NH2 in presence of H2O2. So it is actually cis syn. It will form enethio. Enethio means cis-like compound. Cis-like means both deuterium will be on same side, both hydrogen will be on same side. Second, let's say we have Br, C double bond C, sorry, ethyl, C double bond C, CH3, D and D. We react with NH2, NH2, H2O2. It will form racemic mixture. It will form actually 3O. 3O means trans. Let's say we have above ethyl, then we have CH3, then we have deuterium, hydrogen, hydrogen. It is also cis, so it will form enethio. Sorry, it is cis, it will form enethio. Enethio have this type of compound, but we will be getting, it is optically active. It is optically active, so it will having one more compound which will be mirror image to it. Let's solve some more problems related to NH2, NH2, H2O2. Third, we have cyclohexene. When react with N double bond N, deuterium will have. So how it will form? Hydrogen deuterium, hydrogen deuterium. So this will form like this. And like the sixth problem we have. Now sixth problem, let's look at it is a quite good problem. We have NH2, H2O2. It will form CH3, H and H, which is inactive, optically inactive. But when we react with ND2, it will form HD, MED plus DH and DME. So both are active, optically active. So this is an enantiomer or racemic mixture. That's the difference, because both will attack from the same side. They will attack from the same side. Let's do the last problem. When we react with ND2, H2O2, it will form D D plus D D and CH3 below, CH3 below. So that's how the compound will form. That was the hydrogenation of alkene.